today's video, we will create experiment 6. So first we will create a new project. So we will name it as experiment 6. Then okay, and select the create a blank project. Then okay. So now as we can see, there is a blank canvas and we are going to create a circuit for this experiment, which is a controlled half-wave rectifier with RL load. So first we will gather uh, our voltage sources. So from PSpice source voltage sources, then sign there, and then also since it is a controlled half-wave rectifier, so we will need a controlling voltage in the form of a pulse from sources, voltage sources, and then pulse. Then place it here. And then we will gather the switch break, or known as the S break. So let's search and let's type S break, which is the voltage controlled switch breakout device. Right click and then place symbol. So here it is. Escape to avoid replication. Let's close this first and then rotate. So now we will add the diode, the resistor, and the inductor. So we'll place now the inductor. So we will rotate it by pressing Ctrl R. There. So, and also, don't forget that we should add the ground by pressing G and then OK. So now, the thing, the only thing we could do is to connect those those components by pressing W to wire those. So we're going here and then here. So we should delete this first to avoid shortage. There. So first we would adjust this and then press W to wire the circuit. And now we will try to connect all the remaining open pins to the ground. Then let's try the last one to the ground, and this one there. So now all the remaining components are connected to ground. So now we will Uh, so now we will create, or we will put the values that required. So now uh, we will set the V1 or the V source. So let's rename this first as V source to avoid confusion, and then the V2 as V V control. There, to avoid confusion when we will simulate the circuit. So for let's put values on V source first. So for V source, the value of V off is 0, then enter. The amplitude has the value of 170 volts peak, and the frequency is 60 hertz, then OK, and then the AC has the value of 0. So let's try to hide it, then OK. Now, let's put the values on V1 or on the V control. So the V1 has the value of 0, V2 has the value of 5 volts, the time delay has the value. So since it is a form of an equation, we will put it inside the curly braces. So it is alpha divided by 360 divided by 60, or its frequency. So as we can see, when we're trying to put values as the equation as values, we will put it inside in a curly braces. Then click OK. So for the time rise, it is 1 nanosecond, and for the time fall, it is also 1 nanosecond. For the pulse width, it is set to 80 milliseconds, and the space the period rather is 1 over frequency. We will put it inside the curly braces. There. So for the values of the two voltage source is complete. So let's change the value of R1 to 20 and the inductor to 40 millihenries. There. So now we will try to add parameters since alpha and or the shortened term for frequency on the voltage control is not yet defined. So we will go to place, PSpice component, and search. So we will search for the keyword param, short for parameter. Then enter. As we can see, it is used, param is used to specify predefined parameters. So we will def, define some parameters in the circuit. So right click and place symbol. So we will place it here inside. There. Click escape. So we will close this first. And now we will double click this to open its where we can add properties. So to add the predefined value of the alpha, click new property. So there's a warning. So we will just say or click yes, type alpha in name, and then on the value we will put 45 degrees. Then click OK and click yes again. So as we can see, alpha is added already. So now we will add the frequency, same with the thing earlier. So new property, then we will name it as freq or shorten for frequency. Then the value is 60. Since the frequency we used in the circuit is 60 Hertz. Then click OK. Then click yes again. So as we can see now, uh, alpha and frequency is already added. So to show it in our circuit, let's right click on the name and then display. Let's try it again. So right click, edit, wait, here at the value, then display here. So we will click on the value of the given property, then select name and value to display the property, then click OK. So looking back, so as we can see, alpha is already displayed. So we will do the same procedure for frequency. So click display, then name and value, then click OK. So it is already displayed. Let's save it first. And now we can close this tab by pressing Control F4 here. So now the circuit is already set. So we will simulate the circuit now. So we will go to PSpice, new simulation profile. So let's name it Experiment 6. Then create. As we can see, there is a new tab. Now we will set our runtime to 1 cycle, which is equivalent to 16.67 milliseconds, and its maximum step size in 10 microseconds. So now we will create a parametric sweep. So we will check the parametric sweep, and then we will choose a global parameter, and we will type alpha. So to see the different values of alpha. So sweep type is linear. So our start value will be on, let's say, 40, and the end value is 50 with the increment of 1. There. So we will click OK since everything on the setting is set. So now we will click this Run PSpice button, and now there is a new tab, and we will see that there is a dialog box there. So we will click OK, and now we can add uh, our traces. So looking on the experiment, we will try but for this experiment we will try to uh run the average power first. Let's see. So we will go add trace, average, let's say average power across the resistor, and then okay. So as we can see, when we try to measure those, there is a different values of power. So when we count the number of these colors, so 1, 2, 3, 4, 6, 7, 8. So it's 10. So as we can see, the values ranging from 204 watts are ranging from 183.966 watts to 204.425 watts. When we're trying to plot uh, the average power of the average power with different values of alpha. So let's delete this first, and let's try to uh, add traces. Wait, here. So add traces of the average current across R1. Let's see what we can get. So by measuring the average current of R1 across R1 is ranging from 1.8577 amperes to 2.0116 amperes. As we can see, uh, the peak uh, of each waveform is the same, and it shows all of the waveforms with different values uh, of alpha. This symbols here is a legend, which is for example, this the green square represents when the alpha is equals to 40, and this pink yeah, circle represents when alpha is 44, and the light blue cross, which represents then alpha is equal to 45. So as you can see, when alpha is equals to 45, the average current across the resistor is 1.9377 amperes. So how about its RMS value or effective value for the current? So we will delete all these traces, and then we will add traces, but this time with using RMS, and then we will go to IR1. So as we can see, it is packed, but there are difference in peaks since these are the different values of alpha. So when we are going to measure its RMS current across one cycle, it's ranging from 3.0333 amperes to 3.1971 amperes. So as we can see, uh, the, the values for the RMS or current is quite near, or the only difference is uh, around zero point zero 0.01 or a very small value, while on the average uh, value, we can see that it ranges from almost 1.8 amperes to uh, 2 amperes. So there is a very large difference between these two. But when in terms of waveform, uh, it's almost the same. However, uh, as we can see, the gap between the waveforms are very small when it comes uh, to RMS values. So this means that uh, the uh, the alpha is not uh, does not really affect the value of of the value of the effective current or the RMS current across IR1 or across the inductive load. Hope you like this video and see you again next time.